So one thing that came to my attention, and I wish I had made a screenshot, is that since this is the 2013 version that I'm lecturing with up here, I should just bring my own laptop up here and lecture with it instead. But when I choose New Project, if the one that I chose, it seems like the dialogue for like 2019 or whatever is actually not as user-friendly as this, but I'm sure I'm just making a mistake. We have 2019 open right now.
Start off the same way. I'll show you.
Yeah, so if you click Create New Project, and then there's Project Type, and you can choose console or things like that. Then you have these two choices, console.net framework or net core. If you choose net core, then things start looking different. Okay, so on your version, you'll see two different versions of console app. There's a console application with framework and a console application with core. And which is one of the few options. Let's do next to it. Yeah, the framework is the one that you want. If you choose the one with framework, then you have the ability to adding references to it, like we did when we went down to the side and we right-clicked on it, you know, and added a reference that one day. And it fills in some extra, you know, using statements up at the top. So when you're selecting yours, be sure to choose the one that says Console Application Framework rather than Console Application Core. Core looks better, has more, you know, special labels underneath it, but we want framework. And soon enough, we're going to be doing a WPF application. We could even veer off and do WPF applications right now. But let me be slightly better prepared for that. So let's go ahead and finish Chapter 2, begin Chapter 3, and then we'll do a WPF application on Thursday. WPF meaning we're going to create a graphical user interface with buttons and fields that you can type into, things like that, rather than a console black and white application. So as far as I can tell, we were just about at the end of the chapter. Defining named constants. A named constant, you usually just call them a constant. The only reason that we use the word named rather than unnamed is that a number, just all by its lonesome. If you say, you know, right line parentheses 3, that 3 is also a constant, but it's an unnamed constant, also known as a literal. We have to have too many terms for these things. A literal is an unnamed constant. It's just something that's typed in directly into the code. Doesn't even have a variable name associated with it, although you could store it into a variable if you wanted to. A named constant is created using the keyword const, and it's just something like this. Const, you know, speed of light, you have to give it a type, is equal to, you know, 6.022, well, that's not the speed of light, whatever, right. Okay, let's pick something I actually know. Constant double pi equals 3.14159, whatever, right, and then go on from there. Be a lowercase c, like that. This just indicates that it's not allowed to change the value of that variable later. There's other places where you can use the word const. We will see more uses of it than just to create variables that cannot change. So let's go ahead and create my C# framework console application for Lecture E. So for example, const space int space max underscore files. It is a preference, a convention to name your constants with uppercase letters. So our thing can only open 10 files. Yeah, whatever, right? I just made that up. We're not going to actually use that constant for anything. Another thing you can use constants for is to indicate that a piece of data cannot be changed when it's being passed into a method. What do I mean by that? Well, I'm going to create a silly little method. It's going to be static because I want to call it from main. I'm going to just call it void because it's not going to do anything useful. It's going to be called test, and it's going to take the value of x. And I don't know, maybe it'll just write out the value of x. So if I hit CW tab tab, it fills out console.WriteLine. I ought to just be able to put x there. Now I could conceivably do this. X is equal to 5 before printing it out. And then down here, when I'm going to call the test function, test, like parentheses 10, something like that, then it's not going to print 10 when it gets to this point. It's going to print 5. Maybe we don't want to give ourselves the option of that changing. We can say, you'll hold up. Oh, well, look at that, you can't. Never mind. We will, I guess I am thinking too much in terms of C++. All right, well, this is still worth talking about here. What is going on here? We are passing in a value that gets copied into this. This is what's known as a parameter variable, parameter for short. This is the argument. The value of the argument gets copied in, fills that parameter variable. If that variable then changes for some purposes, like after we print it out, if for whatever purpose we changed it to 0, that has no effect on the data that was passed into it. It has no effect on this argument. Just because we set x to 0 doesn't mean that that changes, right? What if we passed in max files instead? You know, when it runs, it's going to print out 10. Excuse me, max files. Right. This is totally legal, right? We're copying the value of a constant into this variable. The variable is allowed to change, right? But it doesn't change the value of the constant. If we print out, if we write line the value of max files down here, it's still going to be 10, even though this is 0. What if you want to let this function actually change the contents of this variable? What if you wanted to be able to do this? Int my data equals 3. You wanted to be able to pass in my data, and then when you printed it back out, it would show it as 0 because it had gotten changed here. We can do that by using a reference parameter type. REF indicates that the value that is being passed in can be changed by the method. What it means is that this and this are not copies of each other, that x actually is my data. It's like instead of like dealing with pointers, we have 2 pointers to the same address. We have 2 references to the same piece of data. This and this are referring to the same piece of data, so when we change it here, it would change it down here as well. And so if we print out my data as well, then we would find out that it has been changed to 0. And we could prove that to ourselves. However, this is being underlined. And the reason for that is, unlike C++, which also supports references, Java does not. You have to put a keyword here as well, just to blatantly call out the fact that you realize that you're passing in something and that it may change it. That's what the ref keyword means. The ref keyword means don't pass in a copy of the data, pass in a reference to it. And then once it has a reference to it, it can change it. And so if we print out CW tab tab, so after test, comma, my data equals curly brace 0 end curly brace, end quote, comma, my data, we're going to find out that although it started off at 3, it's going to equal 0 afterwards, because that function will actually have been able to change it. Excuse me, that method. All right, I forgot to add my read line at the bottom, so I'm going to debug it without, start without debugging, and at least it won't close it. There we go. After test, my data is equal to 0. So it started off as 3. The method changed its value to 0, and since it was passed in as a reference with the ref keyword, that change actually affected the argument that was passed in. Okay, well that kind of implies, I don't know if it implies something, but what happens if we pass in a constant? Right, what if I tried to pass in max files right here? It won't let me do that. Why? because the ref keyword is kind of a contract saying, okay, we're going to get an integer and we're allowed to have write access, but it was declared as a const. So, the only things you can pass in if you use the ref keyword are things that can actually be changed. That's enough for now. I can go into a little bit more on that topic, but that's enough for now. I'm not even sure how I got from there from talking about constants. Oh, I guess because I have a constant there, and I thought that I could put the const keyword there. So programmers usually name their constants using all uppercase letters with underscores for readability. The goal is to make self-documenting statements easy to understand even without program comments. So an enumeration is a set of constants represented by identifiers. Say that you know that there's only 7 days in a week and you want some value to represent a day of the week, and you don't want it to be able to equal anything other than one of the days of the week. In that case, you create an enum. And so what we're doing here is we're creating an enum of a data type called day of week, and then we're specifying the values that that can be set to. And they don't show using it. Well, we may as well. So let's create an enum. Enum, you don't need to do day of week since that's what they've got. Let's be really creative and call it, for example, months. So enum month. And what are the possible values of month going to be? January, February, March. You just separate them all by commas, and that's it. By default, an enumeration value is an integer. If I displayed, well, we haven't even created a variable of that type yet. Why don't we do that? Now we have a data type called month. So we could say month space fave underscore month equals month dot jan, or Feb, or Mar, right? March. There's only 3 possible values for that variable. It can't be anything else. If we try to store anything else into it, it should not allow us to do that. It should not even compile. If I create month, fave month is equal to, and I say, okay, I want it to be equal to 4 for some reason, it won't let me do that. This is an integer. Underneath it all, these are integers, but they're accessed. We've declared it as a data type, so it has to match the data type. Now we might be able to do some casting. We might be able to say, like that. I want you set to the first month, in which case it would wind up being January. And if you change that 1 to a 1, it would be February. And if you change it to a 2, it would be a March. So you use enums when you just want to provide a discrete set of values for you or another programmer to select from that can be bandied about. When there's not going to be an infinite number of months, there's only going to be 12 months, we can create it as an enum. And then, as we write that piece of data out and read it back in and do things with it, we're pretty much are assured that it's going to be a valid month, that our month is always going to be, one of the possible values. Let's see what happens if we print out fave month. Let's set month fave month equals month dot jan, and then let's just do console dot out dot write line and print it out. Console dot, not console dot out, it's Java. Console dot write line parentheses quote fave month is curly brace 0 in curly brace end quote comma fave underscore month. Is it going to print out a nice fancy name? All right. what have I done here? I've messed this up. He lost his text that he was supposed to be printing out. At one time, he said this, after test, comma, my data equals curly brace 0 and curly brace end quote, comma, my data. Is it just really not liking the fact that I have an enum here? Because he's saying that he wants a closed curly brace now. Perhaps the enum should have gone outside of the method declaration. So I cut the enum and I pasted it above main. That seemed to make the errors go away. Okay, see what I did there? I took the enum, I put it there, and now it's capable of compiling. So I'm going to go ahead and run it. I need to really need to put my read line down at the bottom. So CW tab, press enter to finish, end quote, and then console dot read line. All right, and interesting. This is interesting, and I had forgotten that it would do this. When it was displayed on the screen, C# went to the trouble of taking some numeric value and actually converting it into the word Jan to be printed out. Because this is just an integer. It's just equal to 0. Yet when we told it to right line it, it printed that out, even though that's not a string. Java won't do that, and I'm impressed that C# did. We will learn more about enums. You can do things like specify different types. You don't want it to be an int, you want it to be something else. Or if you want different values, you don't want it to start counting at 0, 1, and 2. You want to count on 1, 2, and 3, and so on. You can do that. So you can specify the data type after the name of the enumeration. So we could put a colon and followed by a data type if we did not want it just to be simple integers. They don't give an example of that. I'm not comfortable with the idea. In my mind, enums are for integers. That's how they've been since 1970, and that's how they're going to stay. No, we could look up, see how to do it. But you can specify a different starting value. You saw that I was saying that I could cast it so that if I set fave month equal to 0, it meant January, and 1 to February, and 2 to March. Well, if you specify a value when you're creating the enum, you can give it different values. Let's create another silly enum. Let's come up here, and we're going to do enum, I don't know, powers, curly brace, 10 equals 10, comma, 100 equals 100, comma, 1,000 equals 1,000. Now if we want to use one of those values, I'm not sure why I called it powers, but anyways, powers, x1 equals powers dot 10 or powers dot 100. Then if I use that for math, int x2 equals parentheses int end parentheses x1 asterisk 20, then it's going to equal 100 times 20. So if we print out x2 now, it should equal 2,000. Tell you what, let's just make that 3. I want to see it say 300 there. And so if you just came in, I'm not expecting you to have caught up. If you feel like it, you might want to just go ahead and do this part right there, and then do these 2 lines. Or we are going to change topics completely in just a moment, and so you don't have to bother at all. But let's write this out. CW tab x2 equals curly brace 0 in curly brace end quote comma x2. And we should see that x2 is equal to 300. because x1 is set to powers dot 100. If we look up here, 100 has a value of 100, integer representation of it. So if we multiply it by 3, we should get 300. Yeah, okay. Alrighty, onward. Different topic. Programmers say that using enums make the values type safe. I like that, programmers say. Is the author kind of like distancing himself from it? Programmers say that using enums make it type safe. But anyways, yeah, it's type safe. Data type for which only appropriate behaviors are allowed. What happens if I try to set something to a completely illegal value? Right, I have that x1 variable. What if I say x1 is equal to parentheses powers in parentheses, and really I think I should have capitalized powers. I think I would have been happier doing that. But anyways, not 100 because that would work, but 101. That is not a valid power. It's not part of the enumerated list. So is it going to yell at me? Is it going to crash? No, it didn't care at all. So much for it being type safe. I'm going to print it out now. Console dot write line parentheses quote x1 equals curly brace 0 in curly brace end quote comma x1. It's not a valid enum. It's not. It cannot possibly be any one of these. So what did it wind up being? 101. Shouldn't let you do that. There's not much point to having an enumerated data type if you're allowed to just arbitrarily assign it values that don't exist. Because now we have a variable that does not equal any of those values. But perhaps I'm not even supposed to be showing you that you can take an integer and cast it to create one of the values. But if I'm not going to mention that, then why would I show you that you can assign them values like that? Oh well. Okay, so this is a little bit dodgy. Giving them values like this, that's how you should do it. Create your variable, you specify the enum name. You could even specify the class name followed by the enum name if you wanted to. This could say, if I delete all that because that was dodgy like I said, program dot powers dot 10, right? Since program is the name of our class, we just specified, you know, in which. It's now a more fully qualified path to which enum we are using. If you had other classes, you could have enums tucked away in those classes. That's why you might want the ability to differentiate which class you're using. So console input. An interactive program is one that accepts console input. The read line method accepts all the characters up until the point when the user hits enter. The characters are assigned to a string, then you must use a sum conversion method to convert the input string to the proper type. And so far we've seen 3 ways. My preferred way is for us to go ahead and use the try-parse method. And this one doesn't demonstrate using try-parse, they show using convert. Convert.toInt or convert.double or something like that. So enter the price of an item. They read the line into a variable named item price as string, and then they convert item price as string into a double by calling convert.toDouble and passing that in as an argument, and they store the result in another variable so that they can do something with it. Ask for the, calculate the total plus the tax rate, multiplied by the tax rate. There are all sorts of conversion types. Boolean. Somebody types in the word true, you can turn it into a Boolean. I wonder if it would also work with treating 0 as false and 1 as true if you pass those two values to Boolean, but certainly true and false as your strings would work to a byte. Okay, you know, any number that can fit into a byte, it should be able to convert it, and so on, to double, to int 16, which is the same thing as a short, to int 32, which is the same thing as a regular int, to int 64, which is the same as a long, to s byte, which is a signed byte, to a single precision floating point number. I guess that's as opposed to a double. And then to an unsigned int, to an unsigned int 32, to an unsigned int 64. Unsigned just means that the values can't go negative, but then they can hold, you know, twice as large a value as they can if they are signed. So whereas a signed short can hold a value between negative 32,000 and positive 32,000, an unsigned short can hold a value from 0 up to 65,000. So the parse method is an alternative to the convert class. Converts a string to a number. Parsing means to break into component parts. Turns it into its numeric equivalent. And then the question becomes, why would you choose one over the other? C#, why use parse over convert? What's the main difference between int.parse and convert.int? Which is to be preferred? If you've got a string and you expect it to be an integer, you'd use int32.parse. If you're collecting input from a user, you'd use try-parse. Yeah, see, that's what I argue. Since it allows you more fine-grained control if the user enters invalid input. Convert.int takes an object as its argument. Well, that argument can be a string, but it can be something else. I guess that's of interest. If we want to convert a double to a float, we could pass in convert to int32 does not throw an exception when s is null, but parse does. They both throw in an exception if there's a problem with it. And all of the uses we're going to come up with, we would probably, well, if we're getting input from a string, I recommend using try-parse. Other than that, I don't have any reason to argue using the .parse method over using the convert class. Can't recommend one over the other. I guess I like convert because I can just type in convert dot and then get a list of data types to convert to. Maybe I'll grow fond of doing that. Try-parse is a superior solution because it doesn't generate an exception if when given bad data. So we know what variables are. We know what constants are. Constants are just constant variables. They're variables whose contents cannot be changed once they're assigned. We can display our variable values with a right or right line. 9 integer data types. Just use int unless you have a reason to make it longer, in which case you use long, unless you have a specific reason to use any of the others. 3 floating point data types, float, double, and decimal. Now, I don't recall this going to any serious discussion of the decimal class. A decimal holds even more precision than a double. So it says that suitable for financial and monetary calculations. Smaller range means that it does not support as large of an exponent. But that's okay if we're talking about, you know, dealing with money. We don't need numbers, you know, to the power of 304 or whatever. The precision is more important than the number of digits you can put in the exponent. It's just another data type. It's just another floating point data type, but it's more precise. It's about twice as precise as a double. So whereas a double is a double wide float, I guess we could think of a decimal as being a quadruple wide float for the most amount of accuracy possible. Wonder if I'm going to change my recommendation to always use decimal rather than always use double. But I think I'm just going to stick with double because that's what you'd be using in other languages as well, Java and C++. Yeah, let's Google up why use C# decimal. Good old Stack Overflow. You can find everything here. I see people using doubles in C#, but I read somewhere that doubles sometimes lose precision. When should I use a double and when should I use a decimal? Do you want fractions of cents like at gas stations? There's actually a fairly answer. Decimal works like a long and an int, but it's got a dot somewhere in it. Okay, that didn't explain it to me. For money, always use a decimal. It's why it was created. If numbers must add up correctly and they must balance, use decimal. Includes any financial storage or calculations, scores, or other numbers that people might try to do by hand. If the exact value of the number is not important, use doubles for speed. Graphics, physics, other physical science computations where there's a number of significant digits. It's not that double is inaccurate, it has relative accuracy. It can represent very large or very small magnitudes. So it's totally possible, don't type this. But if I have a double, this is a valid double, right? That really comes out to something like 1.23 times 10 to the negative 80 or something like that. That's totally fine because doubles will go out to 304 digits, of exponents. So I could stick in, like 100 or 200 things there. This still has the same precision as if I just typed in 123 or 0.123. A decimal value, or the decimal data type, does not support such absurd numbers of zeros, leading zeros or trailing zeros before, because it's designed to have a very specific number of precision so that the math can be done, fairly precisely. I will let y'all read up on that more. In other words, if you're going to be doing monetary calculations, always use decimal in this class, in this language. Why don't we just put that there as a comment, right? For integers, use int as a matter of course, unless you need long values, unless you need numbers greater than 2 billion, in which case use long. You will know if you need to use one of the alternate integral data types, like bytes, shorts, unsigned, and so on. For floating point, use doubles unless it's a monetary calculation or some other calculation where rounding errors should be attempted to be forbidden, in which case use a double, in which case use a decimal. So you just do this. Decimal is equal to, decimal space total underscore pay, right? Decimal hours is equal to 3. Decimal underscore pay underscore rate is equal to 15.10, and then total pay equals hours times pay rate, right? Looks just the same as what we've been doing any other time, but since we're doing money, then we ought to try to, oh, look at that, I got an error here. Represents a double precision floating point number. By default, if you throw a period into a literal, in this language, in C and C++ and Java, it treats it as a double. So how do you represent it as a decimal?
Cast it.
Pardon me?
Cast it.
That would be my Yeah, I'm wondering if that's the only way to do it. Oh, you put an M after it. Okay. There. M monetary. That kind of implies when you'd actually want to do it. Looks like 3 million, right? If you've ever used M as an abbreviation for million. Anyways. So to assign a value to a double, if it's a literal, use the M suffix. To assign a value to a float, which I'd never recommend. Oh, not a double, a decimal. To assign a value to a decimal, use the M suffix. To assign a value to a float, use F, like this. Float F is equal to 3.3. That's not going to work because, like I said, the default value of something with a decimal point, its internal storage is a double. We have to tell it, no, we're not a double. We're not smart enough to be using doubles. We're using the less precise version, so better stick an F there. That lets the compiler configure that number to be a float. And yes, you could cast it as well. That would be totally fine. I would be totally fine with seeing you do that. I'd also be totally fine with seeing you do this. Either one of those work. But we have that suffix, so why not put it back? But since my recommendation is to never use float, I don't expect to ever see you put an F after a digit. Alrighty, I think that's about it for Chapter 2. I'm going to need to upload the Chapter 2 quiz. Let's go look at Chapter 3. Oops. All right. Using Gooey objects and the Visual Studio IDE. Create a form in the Visual Studio IDE. Use the toolbox to add a button to a form. This is actually doing what I threatened us to do. Let's go ahead and see what they want us to do. If you are creating a so-called form, you're drawing out a user interface that the user will get to see. So form is a rectangular graphical user interface object where you can drop other things on it, buttons and text fields and numeric fields and things like that. If we try to do this, you're not going to see this option on yours because it's called WPF now. I'm going to blow past this until I have my little series of steps drawn up ahead of my time in my mind, because this is referring to something that I have in Visual Studio, a new project that I have called a Windows form. Or I'm not even sure I see it anymore, but there's WPF. See, and then there's Windows form. This is a preferred style, and if you did a new project, I don't even think you'd see Windows form. So if you go to like project type and choose desktop, and you limit its languages to C#. No, okay. So, Chapter 3 is about creating a Windows form application. The idea is very similar. But I don't want to start stepping to the PowerPoint pretending like it's going to apply to what you're going to be doing, because this object is, this version, this framework is no longer available. Not sure why. When Microsoft deprecates something, they really deprecate it. They just drop it. You can't do it anymore. You have to use an old version of Visual Studio in order to create it. So, we're done with chapter 3. How about that? We learned fast. Let's go to chapter 4. We will get to the idea of graphical user interfaces. I want to do them Thursday. I just don't want to do them without having all my ducks in a row. But once you start making graphical user interfaces, you may like it so much that you want to turn in everything as a graphical user interface. You can do that. So,
I have a wheelchair appointment, so I do have to leave.
okay, okay.
I'm sorry.
All right, that's fine. I wish we could. I apologize for having to move this to 4:15, and I don't want it just to keep sliding each time, so I figured that setting it to a regular time would be better. So, this chapter is going to be pretty easy because I bet you know what an if statement is. I also bet you know how to use if-else, how to use compound expressions in an if statement, and how to use switch. If you've taken Python and you haven't taken another one of the languages like C or Java, then you haven't seen switch before. Otherwise, you probably have. They're pretty neat. I ain't even going to talk about pseudocode and flowcharts. Okay, fine. We'll talk about flowcharts. If you're looking at something like this, and it's got a diamond in the middle of it like that, that's a decision. The decision will do one thing based on whether the expression is true. It will do something else based on if the expression is false. It may just be a do something or nothing. The false side may not have any blocks at all. It may just fall straight down. That's an if statement. And if it does have two sides, then it's an if-else. I mean, this text is probably too small for you to read, and that's okay. But what this is saying is that if this is true, then I want you to go and do some code. And if it's not true, I want you to do some other code. So way down here, above my press enter to finish, right? I'm going to declare a double, and I'm going to call it, temperature in C. And it's equal to negative 15 degrees. Now I could write an if statement based on it. If the temperature in C is less than 0, then that's the freezing point in Celsius of water at standard pressure. There's all sorts of variables that can be involved if you're a physics or chemistry person, but we're just going to pretend that it's as easy as saying that if it's below 0, it's freezing. So, if it's less than 0, well, why don't we do this? Let's create a string. String state. And if it's less than 0, our state is going to be frozen. Else, it's going to be liquid. Now that's not strictly true, is it, right? What could state also be if we're talking, in real life terms? Things aren't only frozen in liquid. Sometimes, boiling, evaporated. It could be a gas. But this shows an if-else. This is what it would look like if you were looking at a diagram and had only. It had something on one side and nothing on the other. If I could use my hand and cover it, cut that part off, then that would just be an if. If we put the else back in, then it looks exactly like this picture did. Where we have something on one side and something on the other. But as I mentioned, it could be that our thing is boiling here. So we need another clause. We need another expression. And here's what we're going to do. We're going to say else if temperature C is greater than 100, because that's the boiling point of water. And the first person to try to come up with the idea of metric water temperatures said that 0 degrees was boiling and 100 degrees was freezing. You were supposed to count down. Very quickly that was jettisoned, but the idea of something, that went from 0 to 100 was maintained, but the specifics of it being, 0 to 100 or 100 to 0. Okay, so if it's greater than 100, it's a gas. So state equals, quote, vapor. Else, it's a liquid. Now I'm going to shorten up this stuff on my screen, because if your block of code is only one line long, you don't have to put curly braces around it. So I feel like just removing all the curly braces to make the code a little bit more succinct. And there we go, right? We have now demonstrated if statements. I'm pretty dang sure that everybody in here knows what an if statement is. So I don't feel like talking about that too much. What I would be interested in doing is creating maybe a method that would return that string based on the temperature that was passed in. That would be a little more interesting. But why don't we see what the PowerPoint was where it was gonna take us. So a decision structure, choosing between alternative courses of action based on values within a program. All computer decisions are yes/no when reduced to their most basic form. So the if statement is a single alternative. After the if, the subordinate code can be placed in braces. You use braces if the subordinate code is more than one statement long, but if it's only one, you can leave it out, just like I did here. I took out the curly braces because that block of code is only one line long. I do need to make sure I don't make too many assumptions, because the majority of y'all I have had in my other classes, and so I blow past stuff that I expect you to have learned in C++ and Java. And then I remember that there are students here who are coming here from having taken scripting and not C++ or Java. So the syntax is a little bit more different than you. So I need to not just go, yeah, we know what that is. All right, so here's a single alternative if. If the number is less than 5, print A. And then print B. There's no else involved though, so if it is less than 5, it's going to print AB. If it's not less than 5, it's just going to print B, right? We're going to follow this logic, do one thing or nothing, and then we're going to do the next. If the block needs to be multiple lines of code, you just put curly braces around it. It's not like Python where you can try to do this, it wouldn't work. If temperature C is equal to 12, state equals, whatever, I don't know. And then do something else, not sure what. Temperature C is equal to, 3, something like that. I'm going to wind up deleting this code. The problem here is that it doesn't work like Python does, where it's controlled by its indentation. The indenting is just for our readability. It's not like both of these things are now part of the if statement. Only this is part of the if statement. This gets done no matter what, regardless of whether this is true or not. If you want more than one line of code, if you want it to work that way, you got to put the curly braces there in this language. In this and C++ and Java, all the languages that were spawned from the original C syntax in 1970. So a nested if. A nested if is when you need you need to differentiate more possible income that can just be done with one question. What do I mean by that? Oh, they probably have a better example than the one that I'm about to come up with. No, I don't like that example at all. But it does show if the number is greater than low, if that's true, then we have nested an if in here. If the number is less than high, we're going to write this number is between low, and high. That's not a bad way of doing it. I can think of a much better way. Those of y'all who have had other programming classes, tell me how you would have done this instead of creating a nested if. If your entire goal was to check two conditions and then print the result based on both of those conditions being true. Is a nested if the only way to accomplish that? I would have used an and. If number is greater than low and number is less than high. Then we would have been able to collapse it to a single layer, a single question. So the classic example, well, I won't say classic, but the example that I keep seeing in some of the other textbooks for nested ifs would be something like this. Or I'll just make my own up. Let's say that we have an integer to represent our hunger. And then let's say that we have another integer that indicates the amount of money we have. If we are hungry, if our hunger is greater than 2, we're a little bit hungry. Inside there, we need to check to see if we have enough money. If money is greater than 4, that's the minimum cost of food here, or let's just, then we're going to write out CW tab tab tab, go out and eat. We could expand upon this and say you are hungry, so go out and eat. What if we didn't have any money? Else, CW tab tab tab, you're hungry but no money, or not enough money, stay home. And then we could have another else down here for what if our hungry is not greater than 2. These are totally arbitrary values. Else CW tab tab, you're not very hungry. Cool. Whatever, right, no problem. You don't have to worry about it. Okay, so here we have a nested if statement. If our hunger is greater than 2, then we're going to go in here and we're going to execute this block. If our money is greater than 4, then we know this was true. So we know we're hungry, and we also know we have enough money to go out and eat. At least stop at On-Q and get a hot dog. Else we're going to say, we're hungry but not enough money. Stay home. Now neither one of these things was true. Now if hunger was not greater than 2, our hunger was minimal, and we're going to say you're not very hungry. So this is an example of a nested if, and you can nest as many of them as you need to. You could have ifs nested inside ifs, nested inside ifs, nested inside ifs. You can nest ifs inside of else's. We could have another if down here. Like if our money is greater than something, we could tell them to donate it to charity since we're not hungry. Whatever, something silly. But all nesting means is that within one level of indentation, one layer of curly braces, we go and embed another logical structure, an if statement or a loop. So the question sometimes comes up, why are you using double equal signs and why are you using single equal signs? A single equal sign is the assignment operator. It copies a value from the right-hand side into the left-hand side. It does not do the comparison. Use double equal to do comparisons. If, does employee have dependents equals number of dependents greater than 0? That's kind of a more complex syntax than I wanted to talk about at that point. But this expression would be done, and then the results of it would be compared to that. With this syntax, this expression would be done, and then its result would be copied into that variable, which 99.999999% of the time you would not want to embed inside of an if statement. And C++ is happy to let you do that with barely a little warning. Java just flat out rules it out. It will not let you do it in that context. It will not let you create an assignment inside of the clause of an if statement. I believe C# is that way as well. So a dual alternative, when you're going to do something or something else. Is the project under budget? Great, we get a bonus. Else our bonus is 0 and we have to notify the contractor. Let us pause, decide what we're going to do next. Am I interested in this one? Not terribly. Well, we could do this first part pretty easily, though. We know enough about it. Alrighty. So it doesn't even matter whether this is still exercise 14 or 15. I would have to check to see whether they've changed the numbers around. So I'm just going to take out the comments that that's exercises 14 and 15 and just say, write a program named tests that declares 5 variables to hold scores for 5 tests you have taken and assigns a value to each variable. Display the average of the test scores to 2 decimal places. So you'll have to use formatted output in order to do that. And then modify the test program to create a new one that accepts 5 test scores from the user. Well, I don't care about making it a new one. Modify the test program to accept 5 test scores from a user. Calculate the average and display the average to 2 decimal places. And then the rest of this is a matter of filling out the Word document. Just basically eyeball it in your head. What would the result of these be? Notice these are all integers, so the results are going to be all integers. What is 5 times 3? It's 15. Plus 2, 17. So you just say that that's 17. What's 9 divided by 4? Well, these are integers. So it's going to round down. It's going to truncate the result. 9 divided by 4 rounded down is 2. Not 2 point something. 2.25. It's just 2. And then 2 plus 10 is 12. And so what's 10 divided by 3 rounded down? Somebody say it, so I'll go to the next one. All right, Simon, I'm going to look at you. 10 divided by 3, since they're both integers, it rounds down to make a 3. You know, and if you had to, you could actually, you know, put all of this into a program and print it out, right? You could print out these things, but I'd rather you not. modulus. Modulus just means remainder. 10 goes into 21 2 times with a remainder of, well, 21 divided by 10 is 2, but it's not even, right? So there's a remainder.
Of 1?
Remainder of 1, exactly. 2 goes into, 10 goes into 21 2 times with a remainder of 1. That's what that means. And so on. And then what is the value of each of the following Boolean expressions? 5 is greater than 4. Is that true?
Yes.
Looks true to me. Is 3 less than or equal to 3? Yeah, 3 is certainly less than or equal to 3. Is 2 plus 4 greater than 5? So far all of these have been true. Right, but 2 plus 4 is 6. Greater than 5? Sure enough. I'm going to keep going until I hit a false.
False.
That one's false. 6 is not equal to 7, so that one's false. If we scroll down here, if you see exclamation mark equals, that means not equal. So is 1 not equal to 2?
True.
That's a true statement. Yeah. Is 2 not equal to 2?
False.
That's definitely false. I'll fix this up later. And then choose the best data type for each of the following so that no memory storage is wasted. Oh, for Pete's sake. So that no memory storage is wasted. Why am I sticking, why is that sticking in my craw? Because according to my assignment, the number of siblings I have, it's highly unlikely I'm going to have more than 255 siblings. So to ensure that no memory is wasted, I could store that into a byte, so I could declare it as a character. That'd be stupid. You just use it as an int. Your final grade in this class. The population of Earth. Well, Earth does have more than 2 billion people in it, so you would not want to use an int, you'd want to use a long. I tell you what, I'm just going to say, choose an appropriate type for each of the following. Give an example of a typical value that would hold a variable and explain why you chose the type that you did. I don't really care if you explain why you chose the type. I suppose I should. So the number of siblings you have, int siblings equals 3, right? Your final grade in this class. Are we going to allow floating point? Are we going to allow, not floating point? If we're going to allow floating point, we might want to use double. W grade is equal to 97, right? Something like that, or 97.1. That was my final grade. The population of Earth, and so on. The number of passengers on a bus. My recommendation is if it's going to be larger than 2 billion, use a long. If it's smaller than 2 billion, use an int. I'm real dissatisfied with this one, and I'm going to delete it completely. There we go. I don't mind those parts, though. So just write this little program and then also fill in this document with the results of those expressions. That makes sense? Good enough? Alrighty.